This lesson begins our unit on trigonometry. It is Learning Target 1, Special Right Triangles. I can find missing sides and angles using special right triangles. So let's do some reviewing on how we simplify radicals so that we are better equipped to using them when they pop up in the rest of our lesson. So let's simplify these radicals. Square root 18. The square root of 18 can be broken down into two numbers. It can be broken down into a few different pairs, but the pair of numbers that I'm most interested in is breaking it down into the square root of 9 times 2. Why 9 times 2? Because 9 is a perfect square, meaning that when you square root it, you get a whole number. You get 3. So the square root of 18 can be rewritten as 3 square root 2. We square root the 9, but we don't square root the 2 because the 2 does not come out as a whole number. Let's try the 60. The 60 breaks down into also a lot of different pairs. I could break it down into 10 and 6, but neither 10 nor 6 are perfect squares. So the other pair of numbers that we could break it down into could be 4 and 15. So the square root of 60 is 4 times 15. The square root of 4 is 2, and we are not going to square root the 15, because 15 breaks down into a 3 and a 5, and neither of those are perfect squares either. The square root of 80 over 8. First, let's simplify the square root 80, and then worry about the 8 underneath it. 80 can be broken down into 16 times 5. This works out to 4 times the square root of 5 divided by 8. We can simplify this one step more because the 4 is no longer underneath the radical sign. 4 goes into 8 twice, so now my denominator is 2 with the square root 5 above it. Dealing with radicals in the denominator is a little bit different. In order to get rid of it, we're going to have to transform those numbers into perfect squares. So in order to do that, we need to turn the 5 into, say, a 25. We can do this by multiplying this denominator by another square root 5. That way the new denominator is going to be square root 25. But what we do to the bottom of a fraction, we still have to do to the top of the fraction as well. So now the top of my fraction says 15 times the square root of 5. The square root of 25 is 5. I'll rewrite my numerator. And we can do 15 divided by 5 now that the 15 is not underneath any kind of square root sign. So that gives me an answer of 3 square root 5. Let's try the 2 divided by the square root of 10. Let's turn the 10 into a 100 by timesing it by another square root 10. Again, do the numerator and the denominator equally. I end up with 2 times the square root of 10, not 20, divided by the square root of 100. The square root of 100 is 10. And now that I have a number outside of the square root sign on the top and just a normal 10 on the bottom, I can also reduce those. 2 goes in the 10 5 times with a square root 10 on top. Now we can get into our special right triangles. The first special right triangle is the 45, 45, 90 triangle. It's a triangle that has two 45 degrees angles and as well as a 90-degree angle. These are all special right triangles, so they're all going to have a right angle and 90-degree angle in all of them. So what I'm going to write down first, I want you to just watch, and then I'll let you know what you should pause and copy. The special sides of this triangle that we learned in geometry were 1, 1, square root 2. but we need something more like a formula, something that we can use from one problem to the next. So instead of using 1, 1 and square root 2 because our other problems are going to have larger sides, let's instead use a variable. So instead of 1, let's use 1n. The other leg of this right triangle also has a 1n. And instead of a square root 2, let's have a n times the square root of 2. Now we have a formula that we can use in all our problems. Pause the video and copy down those onto your basic formula 45, 45, 90 triangle. Let's try using an example with those formulas that we've created on the last screen. In this problem, we see that there's a 9 in the same position as the n. So I'm literally going to write down that this 9 is equal to n. We also have a y on the other side that has an n on it, so my y is equal to an n. And the x is the side for the n square root 2. Our problem is telling us exactly what the n is. It's equal to 9. So we need to take that 9 and plug it into wherever we see the n. So now it's going to say 9 square root 2, and y is going to be equal to 9. So my x is 9 square root 2, and my y is just a 9. In this example, I'm going to do the same exact thing. I see that I have an x and a y on the sides where there was an n. So y is equal to n, and x is equal to n. The 18 is on the side that my formula has an n square root 2. So 18 is equal to n times the square root of 2. So in order to find x and y, I have to first discover what n is. I do that by using this 18 equals n square root 2. So let's use this to solve. In order to get the n by itself and tell me what the n actually equals, I need to make the square root 2 go away. It says n times square root 2, so I'm going to divide by the square root of 2. This leaves me with an n equal to 18 divided by the square root of 2. But like in the little review problems we did first, we don't leave a square root sign on the bottom. So I'm going to go ahead and turn that 2 into a 4 by multiplying by another square root 2 to top and bottom. So now I have 18 times the square root of 2 over the square root of 4. This is equal to 18 times the square root of 2 over 2, and 18 divided by 2 is 9. So if this is what my n equals, and x and y equal it, then both x and y also equal 9 square root 2. Our second special right triangle is the 30, 60, 90 triangle. Again, don't copy down everything I write down first. I'll let you know when to pause the video once we have our real formula sides. In the 30, 60, 90 triangle, the shortest side is equal to 1. The hypotenuse of this triangle, which is the longest side of a right triangle, is double that, so 2. And the shorter leg, or the middle long side, is the square root of 3. Some students mix up the square root 3 as being the largest side, but if you square root of 3, you get a number that is in between 1 and 2. So it's actually smaller than 2. Now remember, we want to have formulas. So instead of a 1, let's instead have a 1n. And if we're going to double that n, we get 2n. And that means instead of a square root 3, we have a n times square root 3. These are the formula sides, so go ahead and pause the video and write down these sides onto your 30, 60, 90 triangle. Let's use those special sides on this example. I'm going to add each of those pieces as equaling to these sides from this example. The 10 is on the shortest side, so it's equal to n. The y is on the hypotenuse, so it's equal to 2n. And the x is on the shorter leg, so it's equal to n square root 3. Now the problem is telling me exactly what the n is. The n is a 10, so I'm going to take that 10 and plug it into each of these spots. So y is equal to 2 times 10. So y is equal to 20. And my x will have a 10 plugged into that n position. So 10 times the square root of 3. Don't need to do any extra work there. It's already simplified. Okay, let's try this example. I want to find the x. Well, let's put the special pieces next to the pieces of this example. The 18 is the hypotenuse, so it's equal to 2n. And the x is the middle long side, or the shorter leg, because also it's across from the 60. The 30 is the smaller angle, and it's across from the shorter side, which is n. But I don't have that, so it's not going to be helpful for this problem. So what will be helpful from this problem? Well, I have an 18 equal to 2n. This can be solved to give me what the n equals. So let's divide by 2 to get the n by itself. So my n is equal to 9. I'm going to take that 9 and plug it into the n square root 3 to give me my answer for x. X will be equal to 9 times the square root of 3. In our last example, I see that I have an x on the side that would be across from the 30. It is the shortest side, so x is equal to n, which is the smallest side. The y is the hypotenuse, and it's always across from the right angle. It's equal to 2n. So far, the problem hasn't really told me what n is. The 12 is across from the 60. It's equal to n square root 3. So in this problem, it's the n square root 3 equals 12 that's going to help me figure out what the n is. So it can be plugged into the other sides to figure out the x and the y. Let's get rid of that square root 3 by dividing by square root 3. Square root 3's are now gone, and my n is now equal to 12 divided by the square root of 3. I need to get that square root sign off of the denominator, so let's increase the 3 to a 9 by multiplying by another square root 3 to denominator and numerator. So my n will now be equal to 12 times the square root of 3 over 9 times, so 3 times 3 is 9, and I square root the 9 and I get a 3. Reduce this by doing 12 divided by 3, and my n is equal to 4 times the square root of 3. Let's take that answer and plug it into the x equals n and the y equals 2n. So x equals n, so x equals the 4 square root 3, because that's just what n is. So there's one answer. For my y is equal to 2 times n, which is 2 times 4 square root 3. Now be careful with this part. It is just the 2 and the 4 that get multiplied to make an 8. The square root 3 does not get affected. Do not write 8 times square root 6. Do not multiply the 2 and the 3. So that kind of covers the variety of problems that you're going to expect to see when using special right triangles to solve for missing sides. If you have questions, send me a message or write them down in your notebook and share them when you get into class. And always remember to click forward and get to that submit button.